In this video, we're going to take a look at finding the volumes of pyramids and cones. So let's start off with a pyramid. The volume of a pyramid is V equals 1/3 times the area of the base times the height of the pyramid. All right, so previously when we were doing lateral area and surface area, we needed what was called the slant height. But in this case, we don't need the slant height anymore. We need the actual height of the pyramid. And whenever we measure height, we're measuring the height from a perpendicular height from the topmost point to the bottommost point. So here's the topmost point in your pyramid. That's called the apex. And we're going to drop a nice perpendicular line to the base of your pyramid. Okay, so that is your height. This red line is your height. That is what you must have in order to find the volume of your pyramid. So what is the volume of a cone? Well, the volume of a cone is exactly the same formula as the volume of your pyramid. It's 1/3 times the area of your base times the height of the cone. But because a cone has a base that is a circle, we can replace the area of the base with the formula for finding the area of a circle, and we're going to replace this with pi r squared. So again, we don't need the slant height, we need the height of the cone, which when we go to the apex of your cone and drop a nice perpendicular line down to the base, that is your height. Okay, so that is primarily the difference between finding surface area, lateral area, and volume is two of the formulas need your slant height, where the volume needs the actual height of the pyramid or cone. So let's walk through some examples. Our first example gives us the actual height of the pyramid. And if we write our formula down, it's 1/3 the area of our base times our height. And in the example, we're told that this is a square pyramid. I know I didn't write it here, but this is a square pyramid. So let's outline our base. Our base is the bottom of our pyramid, and it is a square. So both sides are 10 inches. So when I find the base, it is 10 times 10, and that is 100 inches squared. So now when I look for the height, I know the height of my pyramid because it goes from my apex all the way down in a perpendicular fashion, right? Here's my perpendicular symbol. My height is now 9 inches. So I just need to plug those into my formula. And you will notice that the 3 and the 9 reduce nicely. So the volume of this pyramid is 300, and volume is in cubed dimensions. So it's 300 inches cubed. This example is good for both A and B on your worksheet. Okay, A and B examples give you pyramids where they give you the actual height of the pyramid. Now, how do you do the volume of a pyramid if you're given the slant height instead? This is very similar to problems C and D on your worksheet. So when I work through this problem, you can work through C and D with this problem. All right, so how are we going to do this? Because we need the height of our pyramid. So again, our base is going to be a nice square, okay, because in the directions they told me this is a square pyramid. So our volume is 1/3 base times height. So our base is going to be, again, 10 times 10, which is 100 meters squared. But now, in order to find the volume, we need the height. And I know my height is this red line right here, and it doesn't have a number next to it. But I do have the slant height. So how can I use the slant height to find the height of my pyramid? Well, if you notice, if I draw a line across here, I have a nice right triangle, which I'm going to draw underneath here in blue. Nice right triangle. This is my height, and this is my slant height of 15. This blue, since my height of my pyramid hits the very center of my square, it divides the side in half. So this becomes equal pieces. So each one of those is 5. So when I go and solve this, I get h squared plus 5 squared equals 15 squared. H squared plus 25 equals 225. So h squared is going to be 200. So when I take the square root of both sides, I get the square root of 200, and I know that the square root of 200 is 2 times 100, and I know the square root of 100 is 10 radical 2, so the height is 10 radical 2 meters. So now that I know the height is 10 radical 2 meters, now I can plug my base and my height into my formula. So I get 1/3 times 100 times 10 radical 2, and the 3 does not reduce with the 100 or the 10, so my final answer is going to be 1,000, because 10 times 100 is 1,000, radical 2 over 3, and my dimensions are going to be cubed, so it's meters cubed. So this problem you can do C and D just like I did this problem. You'll have to draw this triangle that is formed by your slant height, the height of your pyramid, and half one of the sides of your square base. So now the volume of a cone, again, is 1/3 the area of the base times the height, and we see that the base is a nice circle, and we know that the formula for the area of a circle is pi r squared. So we're going to replace capital B with pi r squared. So we need the radius and the height for this. So on your worksheet, one of the problems gives you a diameter and one of the problems gives you a radius. You're going to have to figure out which one gives you the radius and which one gives you the diameter, because for this one we need the radius and we need the height. Luckily they gave us the height of our cone, which is really nice. All right, so the height of our cone is this. It is 4 meters. But they did not give us the radius. They gave, in my problem, they gave me the diameter. So I need the radius, and I'm going to cut it in half, right? The radius is always half of the diameter, so it's 5/2 meters. So now that I have my radius and my height, I can go ahead and calculate my volume. It's 1/3 times pi times my radius squared times my height. And I forgot my squared. All right, so what is my radius squared? Well, square the numerator, square the denominator. 25/4 times 4. So I like to reduce first if I can, and I notice that my 4's reduce out, but my 3 does not reduce. So I'm going to end up with 25 pi over 3. My dimensions were in meters, so volume is meters cubed. Okay, so one of your problems, E or F, one of them gives you the radius, so you don't have to half it. The other one gives you the diameter, and you'll need to find the radius by halving the diameter. All right, so the last example is this weird little, I feel like drawing a little tassel off the end, making it a princess hat. Okay. All right, so here they give us a diameter, but this cone is all slanted. So how do we find the volume of this cone? Well, the volume of the cone, again, we find the perpendicular height, right? The the formula is this, and we know our base is pi r squared, right? All right, so we just need our radius. Here they gave us a diameter, right? This is a diameter because they drew the diameter in. So I have to take half of that. Half of 4 is 2 inches, so my radius is 2 inches. My perpendicular height is this distance, okay? If I continue to draw that diameter out, my perpendicular height, right, the height of my my cone should be perpendicular to the diameter of the base. So my perpendicular height is 5.5. So I'm going to put that in, I'm going to change it to an improper fraction, 11/2 inches. Okay, so now I can plug my numbers into my formula. So my radius I said was 2, we need to square that, and my height is 11/2. So I get 1/3 pi times 4 times 11/2, and I know that my 4 and my 2 reduce to 2. So I end up with, the 3's not going away again, 22 pi over 3. My dimensions were inches, and this is volume, so it's inches cubed. And that is it for the video. G and H are just like this. One of them, they gave you the radius. The other one, they gave you the diameter. So you'll have to take which one that they gave you the diameter in and half it to get your radius.